To practice a little bit about where the elements are on the periodic table and some of their properties that we can already begin to identify based solely on their location in the periodic table, let's go ahead and fill this table in together. So helium in the bracket, 2s2, 2p5, you guys all can recognize that as a noble gas shortcut. What element that would be, again, hopefully we all know by now, that could, again, looking at the periodic table, we can figure out that is fluorine. Fluorine is the element that is about. That, of course, is in the P block. The period it's on, which again is the row, that's going to be the second period. What group it's in, which is a column, is 7, sometimes referred to as 17. The group name, what group it's in, again, this is called the halogens. Second to last group. Then is it a metal or a non-metal? Fluorine is actually a gas at room temperature. Every element in the top right corner of the periodic table is going to be a gas, or it's going to be a non-metal. Some of them, many of them are gases. So that's a non-metal. And of course, its reactivity, because it's a halogen, is actually rather high. Not crazy high, but still rather high. The next one we have is argon, is a shortcut. Continuing from argon, we have 2s2, 3d10. Again, looking at the periodic table, we can identify that as zinc. Zinc, of course, is part of the D block, as you guys can tell right here. What period it's on would be the 4th period, meaning it has 4 energy levels. What group it is, we don't really have a group name for the transition metals. We would just call that a transition metal. That whole center part right here are called transition metals. And again, I don't have enough room to write that, so there is no real group number for that. The group name, again, is called a transition metal. Got a little ahead of myself there, obviously. That would be, again, transition metal. Clearly, that's a metal. All of them are. And their reactivity, again, as I've already discussed, is low. The next one, we have krypton, 5s2, 4d10, 5p3. 5p3 would be SB. SB is also in the P block. It is on period 5. Again, you can tell that because of right there. Period 5, group, I have to look. SB is in group 5. Again, period 5, group 5. Group name, antimony doesn't really have a group name. Sometimes we call that the nitrogen group because it's underneath nitrogen, but there's not really an official name. So the best name we could give it is the nitrogen group, which is a little less than creative. Antimony is actually going to be a metalloid, and I will show you why very shortly. Metalloid. All right, the reactivity of these is low. The last one, we have xenon, 6s2, 4f2. That's way down the very bottom, the actinide and lanthanide series. That is going to be cerium, Ce. That is in the F block. Because of that, again, it's all the way down. As you guys can see, it's in the 6th period. Again, the F block. The group, again, we don't have a group name for that or number. So I'm just going to ignore that. Again, that is going to be a lanthanide. A lanthanide, again, you guys can see on the periodic table, it tells you right here, this is the lanthanides, these are the actinides. Cerium is located right there. So it's a lanthanide. That is a metal. And its reactivity, again, would be low, but potentially radioactive. Okay, so some properties of metals, nonmetals, and metalloids. Some properties, of course, metals are shiny. I know that sounds kind of silly. They have luster, which is basically shininess. They are conductive. They can conduct both heat and electricity. And obviously, they're hard. Metals are hard. Some of them, again, can be somewhat soft. Some of the alkali, the group 1 metals, can be soft enough that you could cut them with a knife or even dent with your own fingernail, but they're much harder than, say, a non-metal, which are liquids and gases at room temperature. So obviously they're harder, but not necessarily hard as, like, say, lead. Lead, silver, copper, zinc, those, of course, those things we build houses out of and airplanes out of, those are all obviously metals. All right, the nonmetals, again, are non-conductive. They do not conduct electricity or heat, which is why oxygen is such a great insulator. Styrofoam cooler, it's not the styrofoam that's the insulator, it's the air that's in the styrofoam that actually causes the insulation. So those nonmetals are great insulators. They are non-conductive. There is no, of course, they are not shiny. They are liquids or gases. Okay. The metalloids, again, I'm going to show you where those are located. These have properties of both. So these are kind of weird. They're kind of metals and non-metals. Okay, so for example, aluminum is a metalloid. We all think of aluminum being a metal, right? Because again, it's shiny. It's you can make it into a thin film like aluminum foil, or you can have something larger chunk of aluminum. But the reason why it's a good metalloid is because it doesn't conduct electricity very well. For example, if you wrap your food, your lunch, your leftovers, or your dinner into aluminum foil, and you put that into the oven, not the microwave, the oven, when you open the oven, you could actually, with your own fingertips, pick up the aluminum foil, as long as I'm not touching, like, say, the baked potato, that will burn you. But if you wrap, a little piece of aluminum foil that's kind of sticks off, you could actually pick that up with your fingertips. The reason is aluminum does not conduct electricity, or excuse me, heat, well, and electricity, does not conduct heat very well. Therefore, it's a very poor metal. It doesn't do a very good job of being a metal, so it's called a metalloid. There's many other examples. So if I'm going to just sketch real quick my periodic table, here it is. There's the periodic table. Again, I'm leaving out the F block. Okay, there's the S and the P and the D. There is a dark, kind of what we call a staircase that kind of goes like this on the periodic table. Every element that's located along this border right here, are the metalloids. So these right here, of course, are all the metals. These are the non-metals, your gases, liquids, soft, other things like that. And then, of course, here are the metalloids. Again, not surprisingly, they are in between the metals and the non-metals because, again, they have properties of both. They're metallic, but they're very bad at being a metal, or they're non-metals, but have properties that resemble those of metals. So at the very bottom, it says, know how to use the periodic table to determine the difference. Again, if you know where it's located on the periodic table, so again, if I was to ask you, and again, you can see the one behind me, you can see the staircase going right there. You might be able to see the dark line. That is, again, the border between the non-metals up here and the metals, which are all those, including down there, all the way down there. Again, you'll see it on your periodic table as well. So if I was to ask you tellurium, you've probably never even heard of tellurium. It's located right there, but notice it's touching the dark zigzag staircase. Therefore, you already can tell me that it's a metalloid. It's a metallic element that is very poor at being metallic. It has properties of both metals and non-metals, okay? Any other element I ask you anywhere over here, you already know it's going to be relatively shiny, relatively hard, good at being conductive of heat and electricity. Now, there is one exception, and I do want to point that out, and that is, of course, helium. Hydrogen. Hydrogen is not a metal. It's actually a gas. So hydrogen, kind of like it belongs over there. It's a non-metal. It's a gas. Again, this is what they filled the Hindenburg with. It's highly reactive like an alkali metal, which is why it's in the first column. It has one valence electron, why it's also considered on the alkali metal column, first group, but it's actually a gas. So you might have noticed that the weirdest two elements that like to break a lot of the rules are the group, or the period one elements, hydrogen and helium. They're kind of they're the bad boys of the periodic table, if you will.